Hello friends, in today's video let me take up the topic sets. First let me define what a set is. Let me write the definition of a set. A set is a well-defined collection of objects. A set is a well-defined collection of objects. So let us see what is the meaning of this well-defined collection. So we might have come across different types of collections in our day-to-day life, like collection of students, collection of birds, collection of animals. So these are some random collections which we come across in our day-to-day life. But mathematically, when we are speaking, we can't take such random collections. We have to take well-defined collections. So let us see what is meant by well-defined collection. See, for example, if I ask you to collect all natural numbers from 1 to 10, then the collection will be so on up to 10. These are the natural numbers from 1 to 10. I will give you one object, say 15. Okay, that is, this is another number I had given you. Now you will be in a position to say whether this 15 belongs to the collection or does not belong to the collection. There is no any ambiguity. You will say that it is not there in the collection, it is not there in the given collection, so 15 does not belong to the collection. um, if I give you number 5, then you will say that it belongs to the collection. Means there is no ambiguity to say whether the given object belongs to the collection or does not belong to the collection. Such collection is called as well-defined collection. Hence, it becomes a set. This is when we are speaking about any collection mathematically. We are very specific when we are giving any definition mathematically. So, we will specify a set in this way. One more example let me take. Suppose if I ask you to collect beautiful birds, collect all beautiful birds, then all of you will not be having the unique or same collection. The collection varies from person to person because it is completely opinion based. Um, Depending on the person, the collection also varies. But if I ask 100 people to list all natural numbers from 1 to 10, all the 100 peoples will be giving the same collection. There is uniformity in the collection because there is a criterion to say what are the natural numbers between 1 to 10. But there is no criterion. If the criterion is specified, probably all the 100 people may give you the same collection. But as it is completely opinion based, beautiful birds, collection of all beautiful birds, 100 people collection will not be same. So in such cases you will get 100 different collections. And if I give you an object like pigeon or peacock, any object is given to you, then there will be an ambiguity to say whether it belongs to the collection or it does not belong to the collection. Suppose first person has listed peacock as the or pigeon as the beautiful bird, and if I give you the object as a peacock, then definitely it belongs to the collection. Second person might not have listed peacock as the beautiful bird, then it does not belong to the collection. Then definitely there is a confusion to say whether the given object is there in the collection or not there in the collection, because there is no uniformity. First of all, there is no uniformity in the collection, so it will be very difficult to decide whether that given object is there in the collection or not. If such ambiguity arises, then those kind of collections are not well defined collections. These are not well defined collections, hence they will not become a set. So this is not a set. Some adjective if you add to the noun, then definitely doesn't become a set. Whereas collection of all natural numbers between 1 to 10, it is a well defined collection. If I give you if I ask you to collect all students of your class, then definitely it will be a well defined collection, because definitely the college will have the records of all the students who belong to your class. So there is a criteria to decide which student belong to which class. So no confusion whether the given object is there in the collection or not there in the collection. So if I ask you to collect all best or the well known or best cricket players, then definitely again it is opinion based. Hence, collection varies from person to person. It is not a well defined collection. So this is what the basic meaning of a well defined collection is. Any random collection, if you take in particular, it won't become a set. If it is a well defined collection, then only it is a set. So this is the definition of a set. Now let me give, I had given you few examples like collection of all natural numbers between 1 to 10, collection of all animals, collection of all birds, collection of all human beings. These are all well defined collection, hence they are all examples for sets. Collection of all beautiful birds, collection of all well known authors or best cricket players of India, then these are not well defined collection, hence they are not sets. Now to represent these sets, like we denote a set by a collection by a capital letter. Like if I ask you to list all natural numbers from 1 to 10, so this is the collection and we name the collection as A. So usually we use capital letters to denote a set and small letters for its elements. Small letters for its elements. So like if I ask you to write a set with the three elements, then probably generally I'm writing a set as ABC to just to distinguish between which is a set and which are the elements. Elements specified by small letters and a set is specified by capital letters. And sets are always means represented using these flower braces. These are the flower braces. We don't use open parentheses, we don't use square brackets. We will be using flower braces or flower brackets to represent the members of a set. Members are enclosed within the flower braces. Now how to represent a set? Representation of sets. There are two representations, two are necessary and two are sufficient. The two representations of a set are, the first one is a roster method and the second one is set builder method. Let us see what we will do in roster method and what we will do in set builder. Roster method is also called as a tabular method. Set builder method is also called as rule method. In roster method, we will be listing all the elements, separate them by commas and enclose within flower braces, like natural numbers from 1 to 5, 1, 2, 3, 4, 5, like this. We will list all the elements, we separate them by commas and enclose within flower braces. So this is the representation of a set in roster form, and this method is most useful when you have a finite set, because finite number of elements means we can all list all those elements and separate them by commas and enclose within flower bracket. There are two rules when you are writing a set in roster form or any set for that matter. You should not repeat the elements, that is repetition of elements not allowed. Repetition not allowed. And the second rule is that order is immaterial. Order is immaterial. That means if you write a set as 1 comma 2 and if you have another set 2 comma 1, these two sets are equal. Okay, a order in which you are writing the elements is immaterial. You can write 1 first, 2 next, or 2 first, 1 next. Both sets are equal. So that is what the method we follow while writing a set in roster form. Let us see what is meant by a set builder form. That is how to represent a set in a set builder form. Suppose the same set, let me consider. While writing in a set builder form, what we do is we will list a general element as x followed by a colon, and then the property to be satisfied by the element x. X is a natural number less than 6. So till 5 the natural numbers will come. So instead of listing all the elements, separating them by commas, what we do in set builder form is we list the general element as x, then followed by a colon, followed by the property to be satisfied by all the members of that set. That is, x is a natural number less than 6. Then automatically it builds the set as 1 is less than 6, 2 is less than 6, 3 is less than 6, 4 is a natural number less than 6, 5 is a natural number less than 6. So this method is called as set builder form. So in the case of set builder form, this flower bracket stands for set of all. This is how to read a set in set builder form, set of all. In the case of roster form, this flower bracket stands for set containing. This is how we will read a set in the roster form. So these two representations are necessary and two are sufficient. If there are more than one representation, then it leads to confusion. Roster method most probably will use for finite sets, and set builder method will be using it for usually for infinite sets. That is because when you have too many members in a set, it is difficult to represent every member and separate by commas. In that case, we will be specifying the property to be satisfied by the element of that particular set. But still, there are few infinite sets which can be represented using roster form, like a set of all natural numbers. We'll write it as 1, 2, 3, and so on. This is though it is an infinite set, we list the elements. We separate them by commas. That is because there is a pattern. Okay, there is a pattern. The next number will be 4, next will be 5. There is a pattern due to which we can represent it in the roster form. Similarly, the set of all integers can also be represented in roster form, whereas set of all rational numbers can't be represented in roster form. We will write them as set of all p by q, such that p comma q belongs to z and q not equal to 0, because there is no specific pattern. Between two rational numbers, again you can find a rational number. Like real numbers also, you can't represent it in a roster form. Like if you want to represent it in a roster form, 0.1, 0.2, if this is the form, then there is one more real number, 0.0, 0.001, 0.0001, like that. So it is impossible, as there is no pattern. We can't represent that set in the roster form. So this is about representation of sets. Let me go into the next section, that is types of sets. Let us see what are the different types of sets. So that is empty set. The first type of set is empty set. Empty set is the one which has no element, which has no elements within it, and it is denoted as phi, the symbol phi, or empty flower braces. See, for example, if I ask you to list natural number, x is nothing, set of all x such that x belongs to n, x is greater than 1, less than 2. I am asking you to list a natural number in between 1 and 2. There is no natural number in between 1 and 2, hence it becomes an empty set. This is the first type of set. See, before going to the next type, let me define some standard sets here. Standard sets are nothing but the set of all natural numbers. It is denoted as capital letter N. It starts with 1, 2, 3, and so on. The set of all natural numbers. Then the set of all integers denoted as Z, 0, plus or minus 1, plus or minus 2, and so on. Positive, negative, and 0. Set of all whole numbers denoted as W, 0 is included, rest all same as natural numbers. Then set of all rational numbers, they are all of the form P by Q, such that P, Q are integers and Q not equal to 0. Then set of all real numbers denoted as capital R. It is a union combining rationals and irrational numbers. Rationals and irrational numbers. Irrational numbers are nothing but these are the numbers of the form like root 2, root 3, root 5, root of p, where p is prime number, are all irrational numbers. Along with that, pi, which is a non-recurring, non-terminating digits after the decimal point. If you have, then it becomes an irrational number. So combination of rationals and irrational numbers together is called as a set of all real numbers. So these are some standard sets: set of all natural, set of all whole numbers, set of all integers, set of all rational numbers, and set of all real numbers. One more set is set of all complex numbers. If you want, you can remember set of all complex numbers as well, as denoted as C. It is all the elements of the form A plus IB, A comma B belongs to R. So such numbers are called as complex numbers. So why I specified? Because whenever you are using this kind of notation, belongs to n means it is a natural number. There is no natural number between 1 and 2, no natural number between 2 and 3. Similar, there is no integer between 1 and 2, no integer between 2 and 3. Okay, so that specification you should remember. Let us go to the next type of set, that is singleton set. The name itself says what singleton set is. A set having only one element is called as a singleton set. See, for example, you have same example. Let me consider a is equal to for x such that x belongs to n and x is greater than 1 less than 3. You have to list a natural number between 1 and 3. There is only one natural number, that is 2. So this set is called as a singleton set, a set having only one element. Next type of set will be finite and infinite sets. Finite and infinite sets. A finite set means a set with the definite number of elements. A set having definite number of elements. That's called as finite sets. Definite number of elements in the sense you can count those elements. Say for example, a equal to 10, 20, 30. There are 3 elements, so it is a finite set. Whereas empty set is also called as a finite set. A set which is either empty or having definite number of elements is called as a finite set. Otherwise, it is called as an infinite set. Example for infinite sets: natural numbers, integers, and so on. So this is about finite and infinite sets, and number of elements in any finite set is denoted as n of a. N of a is nothing but number of elements in the set A, which is also called as cardinality. Cardinality of the set A. That's about cardinality of a set. That all deals with the number of elements. Next will be equal sets. Equal sets. Two sets are said to be equal. A and B are equal if they have exactly same elements. If they have exactly same elements. Okay, see for example, A equal to 1, 2, 3 and B equal to 3, 1, 2. Okay, these two sets are equal. A equal to B because they have, though the order is not same as A, order is immaterial, you know, exactly the same element. 2 is there in this, 1 is also there in this set. Therefore, these two sets are called as equal sets. Next, equivalent sets are nothing but equivalent sets. A and B are said to be equivalent if number of elements in A equal to number of elements in B. That means if they have exactly the same number of elements. They need not have exactly the same elements. They should have number of elements equal. Say for example, A is 1, 2, 3, 4, 5 and another set B is equal to A, E, I, O, U. Okay, these are the two sets. Now, number of elements in A is equal to 5, number of elements in B is also equal to 5. So therefore A is equivalent to B, means we can generate a one-to-one correspondence between the elements of set A to the elements of set B. So then we call such sets as equivalent sets. I hope it is clear about equivalent sets. Next will be, I will include all these power set and universal set also within the type of sets. Power set. Power set is nothing but it is the collection of all subsets. The collection of all subsets of set A is called as power set. So power set is denoted as P of A. So here I'll name the power set is nothing but P of A, where if A is the set, then its power set will be denoted as P of A. See for example, let me take A is equal to 1, set containing one element, then power set of A is equal to null set is a subset of every set, A is a subset of itself. These two things you have to always remember. These are called as trivial subsets or improper subsets. Other than these subsets, if the given set has some other subsets, then we call them as proper subsets. For example, one more, 1, 2, set containing 1, 2, P of A will have, empty set is always a subset because, then set containing 1, then set containing 2, then set containing A. Okay, then if A equal to set containing 1, 2, 3, you have to list all its subsets. P of A will be equal to null set is subset of every set, and set containing 1, set containing 2, set containing 3, then set containing 1 comma 2, then set containing 2 comma 3, then set containing 1 comma 3, then set A. So these are its subsets. So if you collect all the subsets of a given set, then that becomes a power set of the given set. Say for example, now A has two elements here, one element here. Now P of A will have two elements. A has two elements, P of A will have four elements. A has three elements, P of A will have eight elements. So there is a connection between number of elements in A and number of elements in P of A. This can be written as 2 to the power 1, this is 2 to the power 2, to the power 3. Therefore, if your number of elements in A is equal to m, the number of elements in P of A will be equal to 2 to the power m. That is the formula to calculate number of subsets of a given set A. So that is all about power sets. Even before power sets, I would have explained you about subsets. Let me take this subsets now. We will say that A is a subset of B. This is the notation. A is a subset of B if every element of A, if every element of A is an element of B, is an element of B, then we call it as A is a subset of B. For example, A equal to 1, 2 and B is equal to 1, 2, 3, 5, then A is a subset of B. We will write because 1 is there in A, 1 is there in B also. 2 is there in A, 2 is there in B also. Other than 1, 2, there are extra elements in B. We are not bothered about those elements because we are checking is A a subset of B. This is true. Now, is B a subset of A? Is B a subset of A? This is not true. That is because every element of B is not there in A. That is because 1, 2 are there in A, but 3 belongs to B. If you show one element which is there in B, which is not there in A, then that is enough to say that it is not a subset. 3 belongs to B, but 3 does not belong to A. Hence, B is not a subset of A. In that subset also, again, there are two categories. One is proper subset and one is, proper subset and superset. Proper subset and superset. Proper subset means A is a subset of B and A not equal to B, because we already know that empty set is a subset of any of the set and A is a subset of itself. These two are trivial subsets. So proper subset means it is a subset of the another set, but it is not exactly equal to B. Means there are few elements which are not in A, but there which are in B. Every element of A is in B, but B contains at least one element more than A. Then it becomes a proper subset. A is a proper subset. A is proper subset, and your this B becomes a superset because B is bigger. B is bigger than A. Like 1, 2, I had told you. Then 3, 5. See 1, 2. This is your B. This is your A. In this case, it is a proper subset, and B will be a superset. So if when you collect all the subsets, then it becomes the power set. And number of elements in power set will be 2 to the power m, where m is the number of elements in a given set. Next will be universal set. Universal set means it is denoted as capital letter U. Universal set means of which all the sets under consideration are subsets. So a set of which all sets under consideration or under discussion, whatever we have considered there, under consideration are subsets. Then such a set is called as a universal set. For example, I have taken A equal to 5, 10, 15 and B equal to 2, 4, 6. These are my sets. So for these two sets, I can take a universal set as 1 to 20. 1, 2, 3, so on up to 20. Or else I can take universal set as set of all natural numbers. I can take universal set of all integers. Anything, set of all real numbers, rational, anything fine. But that should be, whatever the universal set taken, that should be bigger than the considered sets A and B. Okay, that should be bigger than the considered sets A and B. Hence, it becomes a universal set. It is denoted by capital letter U. This is about types of sets. And one more thing, whenever you have a set A equal to, this is some basic information like 1, 3, 5. If an element is given to you like a 3, then you have to check is it there in the collection or not there in the collection. That is, we will say belongs to the set or does not belong to the set. 3 belongs to A. If it is there, this symbol belongs to. If it is not there, then we'll write 3 does not belong to A. So, but now it is not possible because 3 is there. 2, if I consider, 2 does not belong to A. So, these are the basic symbols which are used to write whether the given element is there in the set or not there in the set. Similarly, you can have some conversions also, like converting from set builder form to roster form and roster form to set builder form. Conversions are like this. So these are some basic problems. If you have a set like this, A is equal to the set of all 2, 4, 6, 8 and so on. So in this case, if you want to write it in the set builder form, x such that x equal to 2n, n belongs to n. This is the set in the set builder form. Same set represented in the set builder form. Or you can write set of all x such that x is a multiple of 2. Okay, is a positive multiple of, because it has only 2, 4, 6, 8. Positive multiple of 2. Okay, the any way fine, just you have to mention the property to be satisfied by every element of this that particular set. So in the entire video we started with what is the definition of a set, some examples for set, how to represent a set, set builder form and roster form, then different types of sets starting from empty set, finite and infinite set, singleton sets, then subsets, power set, universal set. These are different types of sets. In the next video, I'll be coming up with the Venn diagrams and the different kinds of operations and sets. That's all for today. Thank you so much.